Hello again. It has been a while. I've been busy, and I also have another laptop, so that took some setting up. But I would like to continue where we left off. Last thing we did was add a servo to our board. What I would like to do today is add a stepper motor. So first, let's us catch up where we were. We connected a servo, so on pin 2. Let me get that in there. Yeah, so we in our code we had our LGB channels, and we also added a servo that was connected to pin GPO2, this one. Today I want to add a stepper. A stepper motor is a special kind of electro motor that you can control pretty precisely by giving specific pulses, so it will move in a certain direction. And if you give the certain frequency of those pulses, you can move it at very precise directions and speed. To do that, let's get into our setup. Like here, this is my desk now. You can see the servo is right here, and let's see if it still works. We go to the Thunder client. So my setup is a little bit different because new laptop, so I can say like 90 degrees, and the popsicle stick turns 90 degrees, and we can turn it back. So that seems to work. But you can also see that I already added a stepper motor. This is a stepper motor. It's called 48J something. It's basically the cheapest stepper motor money can buy. They cost about 2 or 3 euros each, so about the same as a beer. And they are not very fast, but they are pretty precise because there's a huge gear reduction in it. So even though there's a very small electric motor in it, there's quite a bit of torque. What does that look like in terms of the actual setup? So it has, first of all, this is the motor. I added the thingy to it so you can actually see that that's moving. And it also includes what we call a driver, and that's a sort of board that, that's part of the engine electronics to make sure that you don't have to feed it straight from your controller. So basically they're always sold together, so I guess it's possible to drive it without, but why bother? So you'll get them together. You can plug the motor in. That has a special socket that fits perfectly here, so that's all right. Then you have 4 pins here. That are the 4 spools, basically. They're not, I think, technically 4 spools, there are 2, but it kind of looks like that. I'll explain in a minute. So there are 4 pins you need to control. That's the important part. And there are 2 more, a plus and a minus, or like a plus voltage and a ground. And that's you can feed it from not the board itself. It's the same with the servo. If you recall, the servo now we do power straight from the board. I'll need to move it in a little bit further. So the servo is in like here, and it's powered from the board now, but it doesn't need to be, right? You just want to power the pulses from the board, but often, especially if it's a big servo, there's no way you can power it straight from the electronics. Same with the motor. So for the motor, if I would power it straight from the board, I couldn't even get it to move at all. So we need to have an external power supply. I think the range of voltages is pretty big for these steppers. So I think it said something like between 5 and 15 or something like that. I ended up using 7.5 volts, and that seemed to work just fine. So I don't really have a reason to use more than that. but straight from the board it doesn't seem to work. So how that looks like, here we have, maybe I can just for now increase the size of the camera a little bit. Yeah, something like this. So we power these two wires, the ground and the plus, to this end of the controller board, of the driver board, and then we have 4 pins that we connect to the microcontroller. So let's get to the code. Let me scale back this again. We don't need it at all for now. Let's go here. Okay, so here we are where we left off. So first of all, where I connected them, that was the pin next to the servo pin, which was pin 2. That's pin 3, 4, 5, and 6. And these are basically the same, or largely the same as the one we were using for the LED channels. And I think there are enough pins, but I'll have to be creative in finding, especially if they have to be adjacent for my plug to work. So I'm going to remove this code for now, and it will. So that means that controlling the motor will also control the LEDs, but we have made that point, so we can remove it now. So I'll start removing that and see all the things that need removing now. So there's like the channels that are removed. I think we can also remove this timer. Is out of here. And I suppose this whole thing can go from here until here. Okay, so now we have just our servo. Fair enough. There's possibly quite a bit of other dead code, but that's not a huge concern right now. So we had our pin for the servo. So let's do a small amount of, well, let's do at least an attempt at doing a bit of code structure. So let's create a new file. Let's call it stepper.rs. And let's add it here, otherwise it doesn't compile at all. And then create some kind of control structure to address that stepper. So we have, let's make a struct. And that struct has 4 pins. But in order to do that, we don't really want to hard code exact types, because actually every pin is a different type, and that's a little bit of yeah, we could hard code it, but it's better to use some generics so we can easily reconfigure it if need be. So let's call it like 4. We need 4 generics for 4 different pins. So, and for that we need output pins. So that's one output pin. The next generic. Let's get this thing out of the way. And W. Something like this. And what's it complaining about? It's never used. Yeah, fair enough. So we need to address those pins. So let's call it pin 1. And we can make it an output pin, but we can also wrap it straight away, because we need actually a pin driver. And the pin driver wraps around the actual pin. We need to define a lifetime for that one, and in this case it doesn't really matter. We just want everything to yeah, survive for the entire lifetime of the process, because that's embedded generally. So we can add the static. We use the T here, and we say that it needs to be in output mode. Need to import that one, this one. So that's one of them, and let's add the other three. 2, 3, and 4, and they need to have the other generics, of course. V and W. So now we have a structure that can do it, more or less. Let's create an implementation. So then we need to have the same block for stepper. And now we can add some methods. So let's start with creating a constructor, new, that will take the 4 pins. So let's use our generics again. V4W, and that will return a self. Alrighty, so let's just create the struct for now. Let's see how far we get. And the only thing we need to do here is wrap the pins into pin drivers. So we create a pin driver, an output pin, and we add pin P1 in this case. And what does that return? Our result. Yeah, let's unwrap it. So this is pretty much the same for all of them. So let's put it on different lines. Same thing. Copy it in here. P1, P2, P3, P4. So now we can instantiate this thing based on the pins we have. What's next? Let's think a little bit about how stepper motors actually work. We can't just send a pulse. We have 4 of them, and the way to look at it right now, it's not technically entirely true, but the pins are like on the sides of a compass, like north, east, south, west. And if we want, for example, to rotate the shaft clockwise, we pulse the north one, then the shaft to align to that one, then we pulse the east one, then we pulse the south one, then we pulse the west one, etc. And keep going, and then it keeps rotating. If we want to go the other way, we go north, west, south, east, and then it's counterclockwise. So there are actually more ways of doing it. You can also, for example, start by pulsing north, but if I want to turn east, I first switch on the east, but I leave the north one on as well. So it's kind of in between on northeast. Then I depower the north one, so it's east. Then I power on the south one, so it's southeast. So you have like between every step you have another pulse. That gives a bit more control. But there are many options of doing that. But right now we're gonna go to for the simplest one, which is kind of what we call simple stepping, and that's just energizing one at a time. So Let's add another function here that does something like that, and we call that function step. And step will take some kind of integer. Let's take a big one, I46, 64. And that will perform a step. But what we need to do is basically make based on this number, we want to create one of the 4 steps. So if this number goes up, we're gonna rotate clockwise, I suppose, and when it goes down, we run counterclockwise. So what we're gonna do, so we can say if step modulo 4 is 0. So that's like for the conceptual north position. Then what we want to do is that we're going to go, I forgot to self. I think it needs to be mutable. So we take the first pin and we're going to set it to high. Now that does not imply that because we set this one high that the other ones are low. So we need to set the other ones to low. So we say P2 set low, and we copy those 2, 3, 3 and 4. And why is complaining? It should be handled. Yeah, fair enough. We unwrap it. It could fail, technically. We can't really do anything about that at this particular point, so we just unwrap. So now we have like 1/4 of the compass done, and that will energize the first one. So let's continue. So for step 1, if it's 1, that's the next one. So this one goes to low, and this one goes to high. Now this one goes to high, this one goes to low, this goes to 2, this one goes to 3, and then finally the last one goes to high, the first one goes to low. Alright, so by setting this to a step, that should align the shaft in a certain way. Yeah, it looks okay. Finally, we might need, we should make them public in any case, because it's not in the same module. And I guess this one as well. We also need a way to depower all the coils, because right now, so if I rotate a little bit, that coil is still pulling at the shaft to keep it in a certain position. And there are moments when you want that, when you want the stepper motor to actively try to stay in its position. But for this ones, there is a huge amount of gearing in it, so actually the motor spins quite fast, but the actual shaft does not. So it will stay in position anyway. And as I have found out, if you just forget it and leave it on for a while, that motor gets pretty hot. And I guess if you use higher voltages, it gets hot a lot quicker. So let's add one more stop function, also with a mutable self. And that will just take all of those and this one. Need to add function, yeah. So we have a stop as well. So whenever we're done, we should call that one. Okay, let's see if we can incorporate this into our main function. So let's add another handler, right? So I think then we need to call f and handle again. So, or do we need to do it afterward? Yeah, we need to do it here. Let's call it stepper. I don't know. And let's keep it easy. For now, we just do a get. Oh geez, there are a lot of those. I guess this one. Let's see. There's so many. It's easy to get. Let's find the post. HTTP method post. That seemed to work, so let's add that one. And then so I'll just add get here, and then like before, I will do a move. I'll get a request. I'll underscore it because we're not going to actually use it, and then I can do things. Need to return OK, and then this thing need to unwrap, I suppose. Okay, so first of all, we need to make our stepper thing. Let's, yeah, it doesn't really matter. Let stepper is stepper dot new, and for that we need to get the pins. So that's peripherals pins dot GPIO3, and onwards from that, like 4, 5, and 6. So 3, 4, 5, and 6. So we have a stepper now, and we'll need to make it mutable. So let's try to do the most basic of things. Let's do just a loop. Let's do for I in 0 dot until like 500, something like that. Maybe a bit more. I don't know. And then we go stepper dot step to I. Yeah, of course. So now we have it here, but of course, because we're gonna approach it from different threads, we need to do exactly the same thing as for the servo. So we need to argmutex the thing. So let's do that. Brackety. Now it's argmutex, and then we go stepper dot lock dot unwrap dot step, and that seemed to resolve that. Once we're done, let's should we? Yeah, let's do that. Let's create a temporary variable. This is stepper.lock.unwrap. We just use s here. Mutable s. And let's call s.stop. Stop. As well, so we depower the coils once we're done. Yeah, maybe let's see what that does. So let me get back the camera. let's flash it. I actually think like since I switched laptops, it's a bit of a different command. So maybe the one I had was a bit old. So now I do cargo ESP flash monitor while I remember that it was cargo ESP flash minus minus monitor. I don't know. Probably some update. No, this is not correct. I need to do flash. And then maybe monitor. I'm not sure. I'll just do flash for now. There's some warnings, probably, yeah, like about the color thing we don't use anymore. Nothing major. I will cut this out probably. So nearly done. Okay, let's now call the monitor. It would be nice to find a single command again. It must be somewhere. We reset it. Okay, so it's trying to connect to the Wi-Fi. Okay, that seems to be alright. Let's check the IP 169. So let's see if we create another window, curl / stepper. That did not quite work. I think what I forgot was to add some kind of sleep in it, because now it just went through really quickly, which is a kind of dumb thing to forget. Here we go. So we do let me check my notes. What's a good amount of sleep? Because I'm not sure if you need to do the regular one. I'm pretty sure there is specials. No, I don't know. Duration. Oh, is that a thing? This one off. From millis, okay. 1 milliseconds. Let's do 2 milliseconds. I think that should be sort of alright. What's the problem here? Duration and stop. Okay. Something that shouldn't be here. One more warning. I think this is a little bit suspect. One moment. This is okay. this thing mismatch close delimiter. So this one doesn't match with this one. Oh, I probably destroyed here this one. That's what happened. Yeah, okay. Butterfingers. Okay. Let's try again. Kill this one. There's once more. And magically fast forward. Alright, completed flashing. Let's monitor. Started, I suppose. Okay, let's see what this does. Now look at that. Look at that. So, that went actually pretty smooth. So, there is a lot of things to improve here. For example, we block inside the HTTP endpoint, which is kind of a nasty thing to do. So we need to kind of push it in there. We can only turn one way. We can't specify how much. In general, I think that the thread sleeps aren't beautiful. On the other hand, that's the kind of programming model the IDF framework kind of allows. So, fair enough. But yeah, I'm gonna call it here. We have something to play with. So yeah, let me know if you like it, if there's something specific you want to see. I will do a follow-up on this one to get this a bit more, bit nicer, a bit more flexible. Maybe some other steppers. I also have some bipolar stepper motors, which I think are nicer general with the drivers. And yeah, hope you like it. See you next time.